Welcome to Advent of Code 2022, Day 2 in C++. So today's puzzle is about the rock, paper, scissors game. And it's divided into two parts, where the first part you get a listing of the moves made on this form, where the first one is, the left one is player A and the second one is you. So you play these games, and A, B, C corresponds to rock, paper, scissors, and in part 1 you speculate that X, Y, Z defines what you play, and X is rock, Y is paper, and Z is scissors. And then you have this scoring system where depending on what you play, you get let's see, where is it? You get here it is. If you play rock, you get 1 point. If you play paper, 2, and scissors, 3. And then an additional points, 0 if you lose, 3 if you make a draw, and 6 if you win. Okay. So my solution I came up with was this. So first I parse the input into pairs of characters. So the data model here is a vector of moves, and each move is a pair of these two characters. And the parse function just parses two characters at a time, move them into a pair, and push them through the result. Then I just iterate over all these moves, and I accumulate the score. And the score function is for part 1. First, there's some error coding here because I use a mapping table, so I have some errors here checking that I actually have a mapping for the move. But if I have a mapping for the move, the result of this particular gameplay is defined by this map. And this map just maps a move. Where is it? Yeah, score table. So it's a map from move to result. And then I just hard-coded this table. So rock against X is I play then rock, X is rock, and 3 is because rock against rock is a draw, and draw is 3 points. So this is 4 points. And I just fill in this table and return that value. Sorry, get a little confused here. Yeah, here we are. So yeah, nothing much to say about that. Then for part 2, it turns out that actually the X is that you should play for lose, Y indicates you should play for a draw, and Z that you should play for a win. So then I first turn this lookup table into what the result are of each play. So rock is a draw, rock paper is a win, or you lose rather. So the solution here is the same as part 1. I parse into a vector of moves, and then I loop over the moves, and I call the score. But the score now is first to turn the red move from file into an actual move. So I added this decoded move function, and then I just count the scores as normal in part 1, and the decoded move is just I check if I should lose, draw, or win, and then I call this to lose, to draw, to win transformations. And to lose, of course, is what if my counter player is playing rock, I should play scissors, then I lose. Paper against rock loses, and scissors against paper, I lose. And draw is just to return the same move as the other one, and then win is the other way around. So paper wins over rock, scissors wins over paper, and rock wins over scissors. So if you want to, you can join me and I will show you how I developed this solution. So it took over an hour to write this code, and it wasn't because the problem was obscure, it's because I keep falling into these C++ traps. So let's see what happened to me. So I read the solution and then I opened it in Xcode, which I didn't like, but I solved this puzzle in Xcode. And I start by writing some utility routines here. Here's the output stream routine for the move data type that I added. So I'm just modeling the problem here. And I have to look up. I tried the, you can see it here, I tried the copy model and then an O-stream iterator to standard out to try to make a easy logging utility. But I hadn't time to check the compiler error I got here. I still don't know what it is, and I had to scrap that because I don't have time to search for that. But yeah, it would have been nice to have been able to do that. So that was one trap. Okay, so I scrapped that solution and just went for a normal loop instead. Here I decided, after 24 minutes, I decided to make a lookup table. And of course that takes some time to write all the scaffolding code and figuring out the points they should map to. More reading of the problem. So okay, here I have solved part 1, so I moved to part 2 and I just brute force the solution. I start by trying to make the switch statement into the score function, and then I realize no, I can just update the mapping table. So yeah, here I have tried to do that. I thought I could transform the mapping table to actually reflect the actual player 1, player 2. But then I realized I messed up part 1, so I spent some time doing that. So that's note to self, don't screw up part 1 when you do part 2. So instead I move the lookup table into the namespace of part 2 to make it a little bit later I do that. First I do these to lose, to draw, to win transformers. And somewhere here I realize I had messed up part 1. Yeah, here I realize part 1 no longer works because I screwed up the mapping table. And now I spent 1 hour on this problem, but quite soon I fixed that. And then it was a smooth sail after that. So that was a little bit about the traps I fell into solving this puzzle. So hopefully in coming days I will be able to avoid them because the actual problem was quite easy. So that's the whole solution, and if I compile this, okay, so I have a lot of logging here, but and if I do like this, maybe you can see it too. So here's my output for my input, and it was the correct one. So yeah, nothing more to say about that. Please leave a comment in the video below if you have anything to comment. Otherwise, thank you for watching and see you next time.
If you like my videos, feel free to do nothing. Just grab a cup of coffee
and enjoy.